we're going to do a combination reaction. We are using a little ball of copper wire. It has a lot of surface area because it's going to, we need it to react with something that's in the air, so that gives a lot of contact with the air. This container is called a crucible. It is made out of porcelain and it can withstand a lot of heat. You need to get this mass. We are going to weigh it with the crucible and the copper because afterward, when we have our product in there, we won't be able to get it out of the crucible so easily. Then we're going to position our crucible up over a Bunsen burner. There's a close-up of what the copper looks like. Here it is from the side when we start heating this, and we're going to let it get really hot. We heat this for 10 minutes. After the 10 minutes, we're going to see its appearance change. So note the observation that you have about that. And then lastly, we're going to weigh it again. So be sure to get this number. It is the crucible with the substance inside. Let's look at a single displacement reaction, and we're setting up two test tubes kind of in opposite ways. In one, we're going to see if copper can replace zinc in the compound, and in the other, we're going to see if zinc can replace copper. And only one of these can occur because the more active metal can replace a less active metal. So which one is more active? Let's kind of look at what's in these. So this is the zinc sulfate solution. It's clear and colorless. All solutions are clear, but some solutions have a color. So that's clear. And of course, this is the piece of copper. It's shiny orange, like you probably know. The copper sulfate solution is blue, so it is clear. You can see through it, but it does have that blue color, so kind of note what that looks like. And then the zinc metal is down here. It is gray. It has a bubble under it, so just ignore the bubble down there. I will give you a close-up of that piece of metal, but anyway, it's a gray metal. So we set both of these up and they incubate for 20 minutes. And we want to see what kind of changes occurred. And remember that only one of these reacts. And so it's kind of hard to tell with the reflections and stuff going on, but see if you can figure out which one has more definite changes. And I'll show you one more view. So on the one that reacts, both the metal and the solution change colors. Let's look at those pieces of metal that I took out. This is what they looked like before the reaction. And of course, this one that's orange is the copper, and this one is the zinc. And this is what they looked like after the reaction. So make your observations that have to do with the signs or indications of a chemical reaction. This is one of the double displacement reactions. In this one, we are putting some hydrochloric acid in its an aqueous solution, and we are also putting some sodium hydroxide, an aqueous solution, into an evaporating dish. An evaporating dish is a porcelain little bowl that we can use to evaporate off the water. So we mix those solutions together. There is a reaction, and we evaporate off the water. There is water in here because these are both solutions. When we evaporate all the water off, and actually there's a little bit left down in here, but we see this crusty stuff around here that forms, that's a solid kind of crystals. Let's get a close-up. So you can see a little better. There's some crustiness and some little, it looks like sugar or salt crystals, and it's up to you to decide what that solid must be that's left from the reaction. We have another double replacement reaction, or I should say reactions, because we're doing a lot of different ionic compounds, mixing a lot of different ionic compounds together. Basically, it's like this looks, that I put H2SO4 sulfuric acid, a few drops all the way down that row, and then here I put barium nitrate all the way across this way. And so each spot has two different compounds in it. Like this one would have the potassium iodate and the calcium nitrate. So you can see what's being mixed in each one's. Well, you can see that some are cloudy and some are not. All of these solutions that I put in were clear. You could see through them. They had no cloudiness. So what you should be writing down is your observations about cloudiness, and you should know what the cloudiness means. You're also going to identify this unknown, and you do that by looking at the pattern of what precipitates it forms. Your unknown is one of those group 2 cations. In other words, these are the group 2 cations in these solutions, and we're mixing each of those with these different anions. And the thing is that even though I used nitrates for all of these, the nitrate is a spectator ion. So if my unknown were, say, barium acetate, in the chemical reaction, it would react just like this one, that's barium nitrate. So be aware, when you identify your unknown, do not identify it as a compound, because we do not know that anion. Identify it just as the cation with the charge, like that.